Warning, the video you're about to watch contains mathematics at the level of differential calculus, also known as Calc 1. All material has an assumed prerequisite of pre-calculus and a full semester course in trigonometry. A thorough review of prerequisite topics can be found by searching the web.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcome.
Hello, my name is Roy Simpson, professor of mathematics at Cosumnes River College in Sacramento, California. In this video, which is a progression through derivatives at points, we're going to take a moment to talk about interpreting limits as derivatives, because you've worked with limits so far for quite some time in this calculus course, or in your calculus course. But what you don't realize is that a lot of the limits you've worked with actually are hidden derivatives. And so I would love it if you spend a few moments really trying to figure out how to interpret some of those limits as derivatives. For an example, somebody says, I want you to evaluate this limit. Now, you totally could just evaluate this limit. There's nothing wrong with that, okay? Note that I'm not even saying, what is this? What is the limit? I'm not asking that. I'm not asking what is its value, but I am asking, what does it represent? Notice the format of this is the same thing as the limit as h goes to 0 of f of a plus h, so some function evaluated at, maybe I'll say 3 plus h, minus a function evaluated at 3, the same exact function, in fact, all over h. And this is the definition of the derivative of a function at the point 3. It's actually specifically this definition of the derivative. So that would be f prime at 3 for a very specific function. So not only am I asking in this question, what does this represent? But I'm asking, once you find out what it represents, I need to know, like in language, what is the function and where are you evaluating that derivative? That is, if you look back here, the function, by the way, it's pretty easy to see that it's a derivative at 3 because it's f of 3 plus h minus f of 3 all over h. So it's definitely a derivative at 3. But we need to also say for f of x equals, and actually state what the function is that we're considering here. Well, look at the function. It's just x to the negative first. I should write that in a different color. It's just x to the negative first, because this also is x to the negative first. So that is the function that we're dealing with, 1 over x, or x to the negative first, by the way. It's the same thing, right? So that is that limit. It's not that we know immediately, therefore the derivative is blah. We don't know that derivative. We have to actually do the mathematics to figure out the value of it, but that's not what they're asking here. What I'm really asking is interpret this limit in terms of derivatives. So it represents f prime at 3 for the function f of x equals x to the negative 1. Now, as you move forward in mathematics, you're going to run into limits. And by the time you get to limits like this, let me write down a limit really quickly. So you have this limit right here. If you're willing to actually visualize this in a different way, you could say this is the limit as h approaches 0 of the sine function evaluated at 0 plus h. I think that's pretty reasonable, right? H is the same thing as 0 plus h. Minus the sine at 0, because the sine at 0 is actually 0, right? This is actually 0. So I'm really not changing the fraction as far as its value. These two fractions are identical. They don't look the same, but they evaluate to be the same thing. But this means that we're actually looking at the derivative of the sine function at 0. And you'll lose sight of that as we move forward in the course, or as you move forward in your course. But I'm telling you, it's so much better if you keep that in mind when you see a limit in the future, especially when you know derivatives. So by the time we get maybe another, I don't know, 2 or 3 weeks in to our course or your course, whichever is the reality for your situation, you will already know derivatives. So you'll know what the derivative of, for example, of the sine is. You'll know the derivative of the sine at 0 is going to be 1, for an example. But then somebody says, I need you to evaluate this limit. And you're like, oh man, that was so long ago, limits, man, how do I evaluate that? If you happen to already know the derivative of the sine at 0 is 1, then you might be able to say, wait a second, I think that's actually a derivative. Let me see if I can write it as sine of 0 plus h minus sine of 0 all over h. Yes, I can. Oh, that's the derivative of the sine at 0, and I happen to know that's 1. Great. Beautiful. So it allows you to quickly evaluate a limit if you can see, and this is a big if, by the way, if you can see that the limit that you've been handed actually represents a derivative. That's going to be a skill that I'm really going to want to focus on as I move forward in these videos. I want to constantly bring back stuff that you've seen previously in the course and say, hey, by the way, let's evaluate this limit. Oh, and guess what? You know the sine of 0, or the derivative of the sine at 0 is 1, and that's what we're looking at here. So it may not make perfect sense for you right now, what everything I've just said, but as you move forward, light will be shed onto that. Main thing to note here is when you're handed a limit like this, look for commonalities. Like this is definitely h approaching 0, so this immediately kind of rings a bell in my ear to say this is some type of derivative. And then I look at the numerator and I say, is that just a difference of the same function? Yeah, the function is x to the negative first. Okay, and where are we evaluating that? 3. Definitely 3. One's at 3, the other one's at 3 plus a wiggle. So this is the derivative of x to the negative first at 3.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcomes obstacles getting in our way. Cause affects more than we can sometimes see. Things for what they are and work together until you feel at peace. Listen close, don't talk too much that isn't cold. Sure, you may really hurt inside. It doesn't justify you to speak too loud and cry.